Hello student, how are you? I hope you are doing well. You might have gone through the part 1 of basic integration. In the part 1, you might have seen the integration is nothing but the application of algebraic, geometric and trigonometric formulae. I am again now ready with the part 2 of basic integration. In this integration, I am going to deal with those formulae and those parts which are not done in the part 1 of basic integration. So let us start the part 2 of basic integration. In part 1 of basic integration, I had done from type 1 to type 4. Now I am starting with the type 5. In this type, I am going to deal with problems such as 1 upon x square minus a square, 1 upon x square plus a square and 1 upon s square minus x square. So this type of problems I am going to deal in type 5. Under the type 5, first of all I am going to consider integration of 1 upon x square plus a square with respect to x equals to 1 upon a tan inverse of x upon a plus c. After that, integration of 1 upon x square minus a square with respect to x equals to 1 upon 2a log of modulus of x minus a upon a plus x plus c. Integration of 1 upon a square minus x square with respect to x equals to 1 upon 2a log of modulus of x plus a upon a minus x plus c. Let us do some problems on the basis of above three formulae. Now let us try to develop a trick so that we understand the formulae but not memorize them. Even though we memorize, after learning some few formulae, we get confused ourselves. So how to not memorize the formulae? Let us see here a technique, a trick. Suppose x square 1 upon x square plus a square dx integration. How we can do? First of all, we can take a square common. So I get here x square plus x square upon a square plus 1 with respect to x. 1 upon a square is coming outside and it can be written as 1 upon x upon a whole square with respect to x. And after that, it is not in the standard form. To convert into the standard form, what we do? X upon a equals to k. Now differentiating with respect to, as we already learned from the type 1 to type 4, whenever it is not in the standard form, we convert to standard form. So we convert it into the standard form, differentiated both sides, and now dx equivalent to a dk. Now therefore, now this problem becomes I equals to 1 upon a square integration of 1 upon 1 plus k square a dk. Now here a square and a has come outside, 1 upon 1 plus k square dk. The integration of this and this cut down, 1 upon a, and integration of 1 upon 1 plus k square is nothing but tan inverse of k, and k is nothing but a upon tan inverse k, nothing but x upon a. So putting back the value of k value, that is x upon a, therefore I becomes 1 upon a tan inverse x upon a. In this way we can remember the formula without memorizing. Even though we forget the formula, immediately this idea we can click, from this idea we can click and x upon a already equals to k, so automatically our brain remembers that dx equals to a dk. So orally this can be developed without memorizing the formula. Let us see how other two formulae can also be done in the same way. Examples on the basis of this formula. Let us read the formula one time. Integration of 1 upon x square plus a square with respect to x equals to 1 upon a tan inverse of x upon a plus c. Example, 1 upon x square plus 2 square with respect to x equals to how much? Here comparing these two terms, so we find that x square equals to x but a square equals to 2 square. So answer is, before finding answer, a equals to 2. Let us decide what is a. A equals to 2. Now formula is 1 upon a, that is a 1 upon 2 tan inverse of x. In place of x, x only, but in place of a, 2. So it is a x upon 2 plus c. It is a tan inverse. This is the answer. Similarly, one more example, x square plus 3 square. Again, a equals to how much? A equals to 3 when comparison with 1 upon x square plus a square. Then we find that a equals to 3. Now the answer would be 1 upon a, that is 1 upon 3 tan inverse of x upon 3 plus c. Suppose square is not there, some number is there, square is not there. For example, x square plus 5, square is not there. How to manage it? This can be written as 1 upon x square plus, in place of 5 you can write the root 5 square. We know that a can be written as root a whole square. So a becomes root 5. So answer would be 1 upon root 5 tan inverse of x upon, because a equals to root 5, therefore x upon root 5 plus c. Now consider next example, integration of 1 upon x square plus 10x plus 28. How you are going to do? Here is the x square plus 10x plus 28. Here comparing with a square plus 2ab and temporarily forget 28. Temporarily forget 28. A equals to x and b equals to question mark. 2 into a into b equals to 10x. X cut down. 2 ones are 2 5s are, b equals to 5. We could obtain the value of b when you compare with the a square plus 2ab plus b square. We were searching the value of b square. We got b equals to 5. There b square equals to 25. What we do here, to find the integration of 1 upon x square plus 10x plus 28, we write x square, we write 10x and we write 28 little far away. Now what is the b square has come? The b square has come 25. So write plus 25 first and after that write minus 25. That is adding 25 and subtracting 25. Now it is a perfect square. Check out. A square 2ab plus b square, that is x square plus 10x plus 5 square, and these two terms 28 minus 25 become 3. What I can do now? It is a perfect square, so it becomes x plus 5 whole square plus 3 with respect to x equals to 1 upon x plus 5 whole square. 3 can be written as root 3 square to make it a perfect square, but it is not in the standard form, so we cannot operate the integration at basic level. To convert into standard form, that is the first priority. And how to convert into standard form? We can say let x plus 5 equals to k, and we get dx equals to dk. Therefore I equals to integration of 1 upon k square plus root 3 square with respect to k. Now we have already that formula. What is the formula? This one, integration of 1 upon x square plus a square equals to 1 upon a tan inverse of x upon a. Now we can apply that formula. So applying that formula become 1 upon a, that is 1 upon root 3 tan inverse of k upon root 3 plus c. This is the final answer. Therefore integration of 1 upon x square plus 25x plus 28 with respect to x equals to 1 upon root 3 tan inverse of k value, k nothing but x plus 5, putting back the value of k here, root 3 plus c. This is the way we can perform the integration of this given question. Next example, integration of 1 upon x square minus a square type, that is in place of a, suppose x square minus 4 square with respect to x equals to how much? Comparing with x square minus a square equals to 1 upon x square minus 4 square, implies a comparing respective terms. So a square equivalent to 4 square, therefore a square is equal to 4 square, therefore a equals to 4. Now we think about formula, because it is already in the standard form, so directly I can apply the formula 2 into a, that is 2 into 4 log of modulus of x minus a, x minus 4 upon a plus x, that is a 4 plus x, equal to 1 upon 8 log of modulus of x minus 4 upon 4 plus x plus c. This is required solution of the given problem. Next example, integration of 1 upon x square minus 3 with respect to x. Here we do find that square is not there, and without square I cannot apply this formula. To create the square term, I can write it like this: 1 upon integration of 1 upon x square minus 3 can be written as a root 3 square with respect to x. Now comparing with 1 upon x square minus a square, now implies a equals to root 3. Therefore integration of 1 upon x square minus 3 with respect to x equals to 1 upon 2a, that is a 2 into root 3, a equals to root 3, and log of modulus of x minus a, x minus root 3 upon a plus x, root 3 plus x, that is equals to 1 upon 2 root 3 log of x minus root 3 upon root 3 plus x plus c. This is final answer. Example, 1 upon 3 square minus x square with respect to x equals to how much? Let us do the solution comparing with 3 square minus x square with 1 upon a square minus x square implies a square equals to 3 square, therefore a equals to 3. Now according to above formula we can apply here. That becomes 1 upon 2a, a value already 3, and log of modulus x plus a, that is a x plus 3 upon a minus x, that is a 3 minus x plus c, 1 upon 2 into 3, that is a 6, log of modulus of x plus 3 upon 3 minus x plus c. This is required answer. Suppose we have problem 1 upon 4 square minus x square minus 10x. This can be solved. 4x square, and x square term always should be positive to perform a plus b whole square. Here x square is negative. To make it positive, I have taken common, and to make it perfect square, x square plus 10x, this is a square, this is 2ab plus b square. That means b square is missing here. So 2ab equals to 10x. A is already x. Easily we can find out the value of b. X get cancelled. 2 1s are 5s are. So b equals to 5. B square equals to 25. So here 4 square minus x square plus 10x, adding 25 and subtracting 25 with respect to x here. Integration 1 upon 4 square minus x plus 5 whole square minus 25 with respect to x here. Now opening the bracket. Now when you open the bracket, what will become? It becomes 4 square minus x plus 5 whole square plus 25. So with respect to x here, so 1 upon 16 plus 25 minus x plus 5 whole square with respect to x equals to 1 upon 41 minus x plus 5 whole square with respect to x. Now after this it is not in the standard form. To convert into the standard form, let x plus 5 equals to k, then dx equals to dk. Therefore I equals to integration 1 upon 41 minus k square dk. Here is 41 is not in the perfect square form. To create the square there, what I can do here, 41 square and root here minus k square dk. Now this problem resemble to the above formula. So what we can do? Apply the above formula where a equals to root 41. Therefore integration of root 41 square minus k square with respect to k equals to 1 upon 2a, that is a 2 root 41, and log is there, modulus of x plus a, that is a k plus root 41 upon a minus x, that is a root 41 minus k. Now putting back the value of k equals to x plus 5. So 2 root 41 log of, putting the value of k here, x plus 5 plus root 41 upon root 41 minus x plus 5. Modulus is over. Now this can be equals to 1 upon 2 root 41 log of here x. We can group the numbers together, 5 plus root 41 to give the descent shape. नंबर का भी descent shape होता है भाई साहब. So give it to the descent shape, minus x plus c. This is I equivalent to next question. Integration of 1 upon 5 minus 2x minus 3x square with respect to x. Now here we observe x square term having some multiplier, that is 3. That is x square got multiplied to 3. Unless and until we remove this 3, we cannot proceed in a simpler way. To remove this 3, we shall be taking 3 common. One more thing is that 3 is negative. Unless and until it is positive, we cannot use perfect square method. Therefore, we have the 2 jobs here. One is that the 3 has to be removed. Second is that negative sign has to be removed. For that, we can take the minus 3 common. I can take minus 3 common. When I take the minus 3 common, it becomes x square and 2x will become 2 by 3x with respect to x. Now x square term having no multiplier, it becomes easy for us to make a perfect square, to create a perfect square. Now 5 minus 3, here x square 2 by 3x. How to create the perfect square? Idea is, here is a number, 2 by 3 is a number. So write 2 by 3, then multiply by 1 by 2, then say 2 by 6, square it. When you square it, it becomes 4 upon 36. This is the best way to create the b square term. It is a b and it is a b square. Square it. So here I get 1 upon 5 minus 3 x square plus 2 by 3x, adding and subtracting 4 upon 36 minus 4 upon 36. Now 1 upon 5 minus 3, and here is the, it becomes x plus 2 by 6 whole square, and this minus will go outside. When it go outside, it will get multiplied to the 3, as well as the symbol will change, minus into minus plus. So here is a plus 3 into 4 upon 36 with respect to x. Integration 1 upon 5 minus 3 into x plus 1 by 3. Now you can cut inside the bracket and becomes here if possible cut down, no problem. So it becomes 1 by 3 with respect to x. Integration 1 upon 5 plus 1 by 3. Bring all the numbers together and adding. When I add, what I get here? 5, the 15 plus 1 upon 3 minus 3 into x plus 1 by 3 whole square with respect to x. Now 1 upon 16 by 3 minus 3 x plus 1 by 3 whole square. Here again the x plus 1 by 3 whole square got multiplied to 3. Even that 3 has to be taken outside. For that, taking 3 common, taken the 3 common, it is 3 into 16 upon 3 minus x plus 1 by 3 whole square with respect to x. 3 gone away. Then integration of 1 upon 3, 1 by 3 will be outside. 16 minus x plus 1 by 3 whole square. And now here is the 16, make it in the square form. If it is not squareable, you can write root and square. Like suppose instead of 16 there is a 15, then it can be written root 15 whole square. But luckily here is a 16, which can be easily kept in the square form. That is a 4 square equals to 16 x plus 1 by 3 whole square with respect to x. Now we know that integration of 1 upon a square minus x square with respect to x equals to 1 upon 2a. Here is a equals to 4. But here in place of x, there is x plus 1 by 3. It is not in the standard form. First, I wish to convert into standard form. That is x plus 1 by 3 equals to k. Some teachers directly apply instead of converting to the standard form, but I should explain you each and every step. Once you understand, you can skip this step and directly apply the formula of x plus a there. X plus 1 by 3 equals to k. Converting to standard form, I do get dx equals to dk. Therefore, I equals to 1 by 3 integration 1 upon 4 square minus k square with respect to k. Now it is resembling the formula of a square minus x square, where a equals to 4 and in place of x there is a k. So x equals to k. We can apply this formula now. So 1 upon 2a, that is a 2 into 4 log of, in place of x I can write k. So x plus a, that is a k plus 4 upon a minus x, that is a 4 minus k plus c. Now here is k equals to x plus 1 by 3. So writing that value of k now. So it's a 1 upon 8 log of k x plus 1 by 3 plus 4 upon 4 minus x plus 1 by 3 modulus. It is equals to 1 upon 8 log of x plus 1 plus 12 by 3 upon 4 minus x minus 1 by 3, which is equals to 1 upon 8 log of modulus of 3x plus 13 upon 11 minus 3x plus c. Under the type 6, I am going to deal with problems in which in denominator root is present and inside the root either a square or x square is present with plus or minus in between them, such as integration of 1 upon under root of a square minus x square with respect to x equals to sine inverse of x upon a plus c. Second formula I am going to deal with integration of 1 upon x under root of x square minus a square with respect to x equals to 1 upon a sec inverse x plus c. The third formula I am going to deal with is integration of 1 upon under root of x square plus a square with respect to x equals to log of x plus under root of x square plus a square with plus c. And the last formula I shall be dealing in type 6 is integration of 1 upon under root of x square minus a square with respect to x equals to log of x plus under root of x square minus a square plus c. So let us start doing the problems of type 6. Let us do the problems on the basis of this formula. Integration of 1 upon under root of a square minus x square with respect to x equals to sine inverse of x upon a plus c. Example, 1 upon under root of 2 square minus x square with respect to x. When I compare a square minus x square with 2 square minus x square, implies a square equals to 2 square, therefore a equals to 2. So according to the formula, it is equals to sine inverse of x upon a. The a is equals to 2, therefore x upon 2 plus c. Similarly, 1 upon under root of 3 square minus x square with respect to x equals to sine inverse. What is a value? A value equals to 3, therefore sine inverse x upon a, that is a x upon 3 plus c. Integration of 1 upon under root of 4 minus x square plus 20x with respect to x equals to how much? Step number 1. Step number 1, we are having minus 4 minus x square plus 20x. Here x square is negative, therefore you must first make it positive by taking minus common. So 4 and minus I have taken common, so x square minus 20x. So step 1 to make it perfect square, and here is the 20x is there, so 20 into 1 by 2 equals to 10. Square it. When you square it, it becomes 100. That means 4 minus x square minus 20x, addition of 100 and subtraction of 100, and 4 minus, now this much part becomes perfect square, that is x minus 10 whole square minus 100. Now opening the bracket, 4 minus x minus 10 whole square plus 100 equals to 104 minus x minus 10 whole square. 104 can be written as 104 root square minus x minus 10 whole square. Therefore 4 minus x square plus 20x equals to 104 root square minus x minus 10 whole square. Steps can be altered as per as your college teacher. These are my standard steps. If you wish, you can alter the steps, alter the presentation also. There is no hard and fast. Now what is their under root? 4 minus x square plus 20x, that is equals to 104 root square minus x minus 10 whole square. To convert into the standard form, I kept x minus 10 equals to k, therefore dx equals to dk. In that case, I equals to 1 upon I becomes under root of 104 square minus k square integration, and that is with respect to k. And we know the formula, under root of a square minus x square with respect to x equals to sine inverse of x upon a. Here is the function k. Therefore, the integration of this becomes sine inverse of k upon a. A nothing but equals to 104. Now I put the value of k here. I equals to sine inverse k nothing but x minus 10 upon 104 plus c. Therefore, integration of 1 upon under root of 4 minus x square plus 20x with respect to x equals to sine inverse of x minus 10 upon under root of 104 plus c. Consider another example to find integration of 1 upon x plus 5 under root of x plus 5 whole square minus 3 square with respect to x equals to how much? Now, to make it in the standard form, I say x plus 5 equals to k and dx equals to dk, and after that it becomes get converted to standard form. In place of x plus 5 k will come and under root of k square minus 3 square with respect to k. Comparing with k square minus 3 square with 1 upon x square minus a square, and we know that integration of 1 upon x under root of x square minus a square with respect to x equals to 1 upon a sec inverse of x upon a. Therefore, integration of k and k square minus 3 square with respect to k equals to 1 upon a. Here when we did comparison, we had a equals to 3. So formula, as per as the formula, 1 upon a, that is a 1 upon 3 sec inverse of x upon a, that is a k upon 3, because it is a function of k, equals to 1 upon 3 sec inverse of k. In place of k, I can put back k equals to x plus 5. So x plus 5 upon 3 plus c. This is required answer. Find integration of 1 upon under root of x square plus 10x plus 1 with respect to x equals to how much? The primary steps are same as the previous problem. Therefore, after making perfect square, we get 1 upon under root of x plus 5 whole square minus root of 24 square. Now it resembles to the formula 1 upon under root of x square minus a square integration equals to log of x plus under root of x square minus a square plus c. We put x plus 5 equals to k and dx equals to dk and apply the respective formula. Therefore, we get integration 1 upon under root of x square plus 10x plus 1 with respect to x equals to log of x plus 5 plus under root of x square plus 10x plus 1 plus c. This is required answer. Another question, to find integration of 1 upon under root of x square minus 10x plus 5 with respect to x equals to how much? The steps are same, and first process is to make it in the perfect form, and after getting the perfect square form, we can go for standardization. We convert it into perfect square form, that is I equals to 1 upon under root of x minus 5 whole square minus 20. Minus 20 can be written as root 20 square. Now to convert into the standard form, put x minus 5 equals to k, therefore dx equals to dk. We get I equals to 1 upon under root of k square minus root 20 square with respect to k. Since integration of 1 upon under root of x square minus a square with respect to x equals to log of x plus under root of x square minus a square, therefore integration of 1 upon k square minus root 20 square under root of with respect to k equals to log of, it is with respect to k, therefore k will come here, and k square minus root 20 square equals to, putting back the value of k, that is k equals to x minus 5 plus here also x minus 5 whole square and 20 equals to log of x minus 5 plus under root of x square minus 25x plus 25 minus 20 equals to log of x minus 5 plus x square minus 25x plus 5 plus c is the answer. Under this section, we are going to learn about product rule of integration. It is also called integration by parts, that is integration of u dot v with respect to x, where u and v are functions of same variable. Now we are going to learn a new method of integration, that is integration by parts. In this method, the two functions are given to us. One is a u, another is a v. So integration of u into v with respect to x equals to u integration of v dx minus integration of box. What is there inside the box? Inside the box we got two operations. One is the du by dx multiplied to integration of v dx. Now let us do one problem on the basis of u into v. Find integration of x dot e raised to x with respect to x equals to how much? Let u equals to x and v equals to e raised to x. How to select u into v? That we'll see in the next example. First let us understand the formula, how to use this formula here. So I am having u equals to x and v equals to e raised to x. Let us fit into this formula. So u here, so that is the x I equals to, and integration of v dx, so v nothing but e raised to x dx, after there minus, so minus integration of box with respect to x. Here is the du by dx, here is the derivative of x with respect to x, here is the integration, here is a v, that is a e raised to x dx. Integration of e raised to x is e raised to x minus integration. Let us see what is the result inside the box. Result inside the box, derivative of x is 1, integration of e raised to x equals to x e raised to x. Integration of e raised to x is e raised to x plus c. Now we can take e raised to x common. E raised to x common, so we get here x minus 1 plus c. This is nothing but integration of x e raised to x with respect to x. In case of integration, if two functions are multiplied together, we have to select one of the function as a u and the second function as a v. There is a rule to select u and v. This rule is called LIATE rule. So let us understand how to select u and v in case of integration by using LIATE rule. Under LIATE rule, L stands for log, I stands for inverse trigonometric function, A for algebraic function, and T for trigonometric function, and E for exponential functions. Now under LIATE rule, how to decide u and v? For that I got a trick here. The trick, I have written the 5 boxes with the label LIATE. Now I will be writing the respective given function in the respective boxes. That is log 5x, I will write in the log 5x box, and sin 2x I shall be writing in the trigonometric box like this. So who has written first? Log 5x is written first. So who is written first, who is coming in the first box becomes u, and who becomes in the afterwards box becomes v. That is, the sin 2x has come in the latter box, therefore it becomes v. Therefore log 5x becomes u and sin 2x becomes v. In the second example, e raised to 5x I shall be writing in the exponential box, and x plus 5 whole square is I shall be writing in the algebraic box. So who has written first? X plus 5 whole square written first, so that becomes u, and e raised to x has written later, therefore becomes v. Therefore it is u and e raised to 5x becomes v. Similarly, sin 2x I shall be writing in the trigo box, and x plus 2 raised to x plus 1 raised to 5 can be written in the algebraic box. So in algebraic box it is written first compared to the trigonometry, therefore it is u and sin 2x becomes v. So 2x plus 1 becomes u and sin 2x becomes v. In this way under LIATE rule we select u and v. Let us do some problems on the basis of product rule of integration. We need to find integration of x square log x. For that we first decide what is u value and what is v value. To decide u and v, let us draw 5 boxes, and after drawing the 5 boxes write L I A T E, and after writing this, now go to the question. Here is the x square. X square comes under algebra, so write x square under A, and log x comes under logarithm, write under L. So LIATE. Now the log x is written first in the first box, x square is written in the next box, that is the third box. We can call it as a first log x is written, after that x square is written. There are only two functions. Who is written first becomes u, and who is written second becomes v. Now integration of u into v with respect to x equals to u integration of v dx minus integration of box, and inside the box the operation are du by dx multiplied by integration v dx. Therefore integration of x square log x with respect to x, log x is nothing but u, x square nothing but v. So putting into the formula, here is a log x integration of x square with respect to x minus integration of this box, inside the box du by dx, that is derivative of log x with respect to x into integration of x square with respect to x. This is equals to log x square integration is x raised to 2 plus 1 upon 2 plus 1 minus integration 1 upon x, and derivative of log x is 1 upon x, and integration of x square is x raised to 3 upon 3 with respect to x. Derivative of log x is 1 upon x, integration of x square is x cube upon 3 equals to log x into x raised to 3 upon 3 minus this x and this x cut down, I get x square by 3 with respect to x equals to x cube. Algebra is written first, after that log minus 1 by 3 integration x square with respect to x, again x cube log x upon 3 minus 1 by 3 integration of x square is nothing but x raised to 2 plus 1 upon 2 plus 1 equals to x cube log x upon 3 minus 1 by 3 into x raised to 3 upon 3 equals to x raised to 3 log x upon 3 minus x cube upon 9 plus c. Therefore integration of x square into log x with respect to x equals to x cube log x upon 3 minus x cube upon 9 plus c. To find integration of x into tan inverse x with respect to x, that is our next example. First of all, we decide what is u and what is v. For that we drawn the 5 boxes, and under the I, that is the inverse trigonometry, tan inverse is x is written, and under the algebra A, that is the x is written. Tan inverse x written first, therefore it becomes u, and after that x is written, that becomes v. Therefore u equals to tan inverse x and v equals to x. Now u into v, integration of u into v equals to u into integration of v dx minus integration, inside the box there is du by dx and v dx, and box is over with respect to x. Now we put the values. The u is tan inverse x integration x dx minus integration of the box, and under the box there is derivative of tan inverse x with respect to x into integration of x dx, and again at the end of the box dx is written. After that tan inverse x as it is. Integration of x is x square upon 2 minus derivative of tan inverse x is 1 upon 1 plus x square. Integration of x is x square upon 2 with respect to x equals to, we first write algebra, after that inverse function upon 2 minus 1 by 2 is taken outside, x square 1 plus x square with respect to x equals to x tan inverse x upon 2 minus 1 by 2, adding 1 and subtracting 1, plus 1 minus 1 upon 1 plus x square. Why we are doing so? Because directly now we cannot do the integration. To make it simpler form, we are adding plus 1 and minus 1, so that the given function, so that this much part becomes divided into the two parts and integration becomes easy. Let's see what happens after adding plus 1 and minus 1. X square tan inverse x upon 2 minus 1 by 2. We can do the two groups. 1 plus x square is a one group, minus 1 upon 1 plus x square. Of course, here is the integration. After that, next step, x square tan inverse x upon 2 minus, the integration will go to each and every part. We get here x square tan inverse x upon 2 minus 1 by 2. Integration of 1 becomes x, and integration of 1 upon 1 plus x square nothing but tan inverse x plus c. Now writing properly, x square tan inverse x upon 2 minus x by 2 plus tan inverse x upon 2 plus c. Therefore, integration of tan inverse x with respect to x equals to x square tan inverse x upon 2 minus x by 2 plus tan inverse x upon 2 plus c. Consider next example, integration of tan inverse x with respect to x. In this example, only one function is given. Two functions are not given. Till now we were speaking u and v, the two functions together. But here the second function not given. Then what we can do? We can write I equals to 1, multiply by 1. Tan inverse x with respect to x. Now, five boxes L, I, A, T, E. Now tan inverse x comes under inverse trigonometry. So here tan inverse x, and 1 comes under algebra. So 1 here, and tan inverse x becomes u and 1 becomes v. Therefore, in this question, u equals to tan inverse x and v equals to 1. Here, applying the formula, integration of u into v with respect to x equals to u integration of v dx minus integration of box, and inside the box I am having du by dx integration v dx. Therefore, integration of tan inverse x with respect to x equals to 1. What is the u? U equals to tan inverse x integration v, that is a 1 dx minus integration of box, and inside the box what is that? Derivative of tan inverse x with respect to x integration of 1 dx. This is equals to tan inverse x and integration of 1 is x minus derivative of tan inverse x is 1 upon 1 plus x square and integration of 1 is with respect to x equals to x. Now this is equals to x tan inverse x minus x upon 1 plus x square with respect to x. Now we can say 1 plus x square equals to k differentiation of 1 plus x square with respect to x equals to dk by dx. 2x equals to dk by dx. Therefore x dx equivalent to dk by 2. Change of kingdom method. So here x tan inverse x minus 1 plus x square is nothing but k. Therefore here upon k and x dx equals to dk by 2. Therefore here dk by 2 will come equals to x tan inverse x minus 1 by 2 outside integration of 1 upon k with respect to k equals to x tan inverse x minus 1 by 2 integration of 1 upon k nothing but log of modulus k to the base e. It is also written as ln k, natural logarithm k. In most of the books ln k also written equals to x tan inverse x minus 1 by 2 log of k nothing but 1 plus x square to the base e, and here of course modulus plus c. This is nothing but integration of tan inverse of x with respect to x. Next example, to find the integration of x into sin inverse x with respect to x. First of all, we draw the 5 boxes and decide what is u and v. So u equals to sin inverse x and v equals to x. Now use the formula u into v with respect to x equals to u integration of v dx minus integration of box, and inside the box there is du by dx integration v dx. So what we do now? Integration of x sin inverse x with respect to x. So sin inverse x into integration of x dx minus differentiation of sin inverse x with respect to x integration of x dx with respect to x equals to sin inverse x integration of x is x square by 2 minus derivative of sin inverse x is 1 upon under root of 1 minus x square, and integration of x is x square by 2 with respect to x. Therefore I equals to x square into sin inverse x upon 2 minus 1 by 2 taken outside integration x square upon under root of 1 minus x square with respect to x equals to here is, we cannot directly do the integration. We have to do some addition and subtraction, that is addition of 1 and subtraction 1. X square sine inverse x by 2 minus 1 by 2. Here adding and subtracting 1 plus x square minus 1 upon 1 minus x square with respect to x equals to x square sine inverse x upon 2 minus 1 by 2. Here 1 as it is, here taken minus common, so it becomes 1 minus x square. Why we did so? Because in denominator 1 minus x square is there. To create the 1 minus x square in the numerator, I took minus common, denominator as it is with respect to x. Equals to x square sine inverse x upon 2 minus 1 by 2. Here again, here is a 1 minus x square is there, that can be written twice in the square root. Any number can be written twice in a square root divided by under root of 1 minus x square equals to x square into sine inverse x upon 2 minus 1 by 2, and here is splitting into fraction. So with respect to x, entire box, this and this cut down. After that, what was left? 1 minus x square is left minus under root of 1 minus x square with respect to x. This is equals to x sine inverse x upon 2 minus 1 by 2 integration of 1 upon under root of 1 minus x square with respect to x minus integration of 1 minus x square with respect to x. Now in the first part we apply integration of 1 upon under root of a square minus x square with respect to x equals to sine inverse of x upon a. In the second part, that is under root of 1 minus x square, that resembles to the under root of a square minus x square. Therefore, in the second part we use the formula x by 2 under root of a square minus x square plus a square by 2 sine inverse x upon a plus c. Now I am going to use this formula in the first and second part. Therefore, integration of 1 upon under root of 1 minus x square with respect to x equals to sine inverse of x upon a x upon 1 equals to sine inverse x. In the second part, integration of 1 minus x square with respect to x equals to x by 2 a square, that is 1 square, minus x square plus a square, that is 1 square by 2 sine inverse of x upon a, that is x upon 1 equals to x by 2 1 minus x square plus sine inverse of x by 2. Now we will using these two results for the further simplification. Therefore I equals to sine inverse x upon 2 minus 1 by 2. Now writing the respective results, sine inverse x, the result of this part is a sine inverse x minus, and result of this part we are writing, that is x by 2 under root of 1 minus x square plus sine inverse x upon 2. Now entire answer is plus c. I equals to x sine inverse x upon 2 minus sine inverse x upon 2 minus x by 2. Here is the twice minus, so opening the bracket it becomes plus x by 2 1 minus x square minus minus into minus plus again, so sine inverse of x upon 4 plus c. Let us simplify. Add all the sine inverse x as a one piece. We have taken sine inverse x common, so here we get this much in the bracket, and after that simplification this much we will get here, and which on simplification gives I equals to 1 upon 4 2x minus 1 sine inverse x plus x by 2 under root of 1 minus x square plus c.